Oh no, why are we talking about the Motorola TV ballast again? Well, in part two of building the ultimate ballast for a Motorola electrostatic TV, in particular this part number, I overlooked something. A rather simple way to add some protection to this, and a number of you pointed out I wanted to address that. So, to recap a little bit, there's a device that plugs into those early electrostatic TVs made by Motorola to do several things. One, these two outer circuits limit current to the tube filaments. This resistor and this resistor are part of the B+ power supply. This is the AC line coming in, and these are branching out to various circuits. So, the original is just resistance wire, and they get very, very hot. So the idea being that, hey, if we can use some modern devices, some diodes, they limit the power going to the tubes and essentially dissipate no heat. But we would like to add protection to this. Suppose we get some kind of power spike and it shorts out one of these diodes, and we're going to get an excessive amount of power going to the tubes. We still get some current limiting through these resistors and the thermistor, but it is going to put a strain on them. We don't want to burn out the CRT filament. What can we do about it? We discussed adding a fuse, but that gets a little tricky because what value fuse, what amperage fuse do you use? If you make it too small, it's going to blow just on the normal surge when you turn the set on. If you make it too big, it's going to take a long time to burn out, especially because we have these resistors. Basically, we can't do it. Using a normal type of fuse, these short out, the current goes up, but not enough to really blow a fuse. So what can we do? Well, there's a really simple trick you can do, and that is to add a reversed bias diode going to the return path. What do I mean by reverse bias? I mean, we don't want it to conduct when we have a positive voltage here. We want it to conduct when there's a negative voltage here. So let's draw a little graph up here. So on this side of the diode we have AC. On this side of the diode we just have, when things are working right, we just have the positive side. And this diode will never conduct, because this diode only conducts when we have a positive here and a negative there, more than 0.7 volts if we're using a silicon diode. So if this shorts out, we're going to get this negative cycle. And this will conduct, and it will look like a darn near a dead short, which will draw an excessive amount of current, which will blow a fuse. So say we use a 2 amp fuse or something like that. Now we also do still have these resistors. So it's not going to instantly blow the fuse, but one of these is going to give fairly quickly. If we use fusible resistors, which I highly recommend you do, this is more likely, I think, to fail than the fuse. But one or the other is going to go. And similarly on this side. So that is my recommendation. We add some diodes, and let's throw a fuse in here. Couple amp, fast blow, 2-3 amp, something like that. You don't want to blow it to turn the set on. There's going to be a little bit of a current spike, but you do want it to blow in this situation. So there you have it, reverse bias diodes. These don't need to be quite so robust as those, I don't think. 1N4007 is a common one that we use in this hobby. All right, I think that's going to do it. If you have any further thoughts or suggestions, let me know. Otherwise, I'm going with this as the final circuit design.